Okay, the next question, what we want to evaluate is this expression. Now, we will never have to integrate that one by itself. That's an extension 2 type problem by itself. But with the first part taking the derivative, we can take the derivative there. And remember, hence means use what you've just done to evaluate this one. So we find the derivative. This is e to the power of 10x. So we derive 10x, which gives us the sec squared x. And e to the power of 10x will just stay the same. So when we have a look there at what we need to integrate, this is the same as what we've just derived. So all we're doing is going to work backwards to e to the tan x. So when we derive e to the tan x, sorry, secant squared x e to the tan x, that's going to integrate back to e to the tan x, and it's going to be between 0 and pi on 4. So we put tan of pi on 4 there, which is going to be 1. That works out to be 1. That's why it's just e to the 1. Tan of 0 is 0. E to the power of 0 is 1. And there's our expression. We've evaluated it. But we had to use what we derived in the first part. In the second one here, we pretty much along the same lines. Find the derivative of x sine x plus cos x, and then evaluate x cos x between 0, integral of that between 0 and pi on 2. So we derive it. We're applying the product rule here. So derivative of x is 1 times the sine x, plus x times the derivative of sine, which is cos, plus the derivative of cos, which is minus sine, and they cancel, gives us the x cos x. Now when we integrate that, it's going to go back to what we started off with the derivative. So we integral of x cos x is x sine x plus cos x, and then we're going to go between 0 and pi on 2. We substitute pi on 2 in, and we substitute 0 in. Now sine of pi on 2 is 1. Cos of pi on 2 is 0. So that's going to give us 0 there. That's all 0. And cos of 0 is 1. So that's where all these values come in. Pi on 2, sine of pi on 2 is 1. So that just gives us the pi on 2. We had 0 minus 1, which gives us pi on 2 minus 1, and that's where that comes from. So again, be careful, drive it properly, but it should have the derivative should have some relationship with that integration that we have to do.